Okay, so I want to look at a couple of different types of static rigid body problem, and these are of increasing difficulty as we go through, but the key point is to really kind of understand the standard process for static rigid body questions, which is that we take moments, tend to take those about where the pivot point is, and then we also tend to take the resolved forces both horizontally and vertically, and all three of those should be in equilibrium, both the moments, the horizontal forces and the vertical forces, and between those we'll come up with some equations which we should then be able to solve. So looking at question 1, I'm told that the ladder is uniform, so here is my 60 degrees. It's on a rough surface, so I know that here I'm going to have a reaction force. We'll call this A, so this is my reaction force at A, and I'm also going to have a frictional force. Just think that if I'd placed this ladder on ice, we know it would slide out to the left, so the frictional force must be pushing it inward. So that's my frictional force, and I can call that my frictional force at A. We know that 2 meters up my ladder, I've got the centre of mass. So that's 2 meters. This is the centre of mass, and the weight is 20 g. Another metre further on, so 3 meters from the base, I've got a force which is coming out of this peg. Remember that it comes out at right angles, it's perpendicular, and we'll call that force F. So helpful to remember that if I look at alternate angles, this angle here would be 60, this angle here would be 30, so I'm looking here at this being also 60 degrees. So that's my 60, so that's a 60 degree angle. Okay, so I can now start by taking moments about A, and I'd typically start by doing this with moments. Remember, the moment is the perpendicular distance from the force. So if I look at, I've got 2 forces, let's look at my 20g first. So if I extend this downwards, the length that I'm looking at here is going to be this length there that I've just marked in with black pen. Well, essentially that's the lever through which the force acts. So here, if I know that this is 2 meters and this is 60, this must be 2 cos 60. So this distance here is 2 cos 60, so I can say 2 cos 60, which is this distance, times by my force, which is 20g, must equal the moment of this force F. Well, this is already acting perpendicular, so this is the shortest distance, is equal to 3F. Well, cos 60 is a half, so it's 2 times a half, which is 1. So I can say 20g equals 3F. Therefore, F equals 20g over 3. Now, so I've used my moments. There's nothing more I can do with my moments. The second thing I'm going to do is to now resolve those forces. Well, here, these vertical, horizontal, vertical. The only one which isn't horizontal or vertical is this force F. So what I'm going to need to do is to resolve that. Now, here, if this is 60, the vertical component then must be F cos 60, and the horizontal component must be F sine 60. So, let's start by resolving vertically. I've got upwards, I've got RA plus F cos 60 equals my downward force, which is 20g. So RA cos 60 is a half, so plus F is 20g over 3 times a half equals 20g. So this gives me RA equals 20g minus 10g over 3, which is going to give me 20g over 3. Resolving horizontally, the only horizontal forces I've got are Fa and F sine 60. Fa equals F sine 60. Sine 60 is root 3 on 2, so I know that Fa equals F, which is 20g over 3 times root 3 over 2. 20 and the 2 cancel to give me 10g, so 10 root 3g on 3. Now, I know that F equals mu r, therefore mu is equal to Fa, this friction at A, divided by Ra, which is 10 root 3 g on 3 divided by my reaction force at A divided by 20 g over 3, which gives me 10 root 3 g on 3 times by 3 over 20 g. Should see here there's lots of nice cancelling out to be done. The 3's cancel, the g's cancel, becomes a 2 and a 1, and I just get left with an answer of root 3 over 2. And that is my coefficient of friction.